This is section 11.2, Arithmetic Sequences, and our objective of this section is to find a formula for any term of an arithmetic sequence. Remember, nth just stands for where you are in the sequence, and then to find specified terms of an arithmetic sequence using that formula. So we want to start by considering the arithmetic sequence 2, 5, 8, 11, and 14. First of all, we'll show that it's arithmetic because the common difference between those first two terms is 3. And that common difference holds up no matter which two terms you're talking about. So to get from 5 to 8, you'd add 3. From 8 to 11, you'd add 3. And then from 11 to 14, you'd add 3. To help us determine how to find any term of a sequence, we're going to first determine how to find the fifth term of this sequence. 14 is the fifth term. And you'll notice that in order to find the fifth term, we started at the first term, and we added the common difference 4 times. This pattern follows directly from what we did on the worksheet in class today. Hopefully you noticed that anytime you were looking for the fifth term, you would add a common difference 4 times. If you were looking for the seventh term, you added a common difference 6 times. And we can use that to find terms that you wouldn't want to find by writing out all of the possibilities. So we can continue this pattern for the 100th term. If you wanted to find the 100th term, you would simply add the common difference 99 times. It's 99 because you don't need to add anything to get to the first term. You already start there. So everything after the first term you have to add to get to it. And of course, this isn't just true for the 5th term or the 100th term, but it's true for any term. If you want to find the nth term, you add dn minus 1 times. So here's the formula that we've come up with. In order to find the nth term, that's t sub n, you start with the first term, and you add d n minus 1 times. So here's an example. We want to find the formula for the nth term of the arithmetic sequence 13, 4, negative 5, negative 14. First, we need the common difference, and I notice that to get from any term to the next, you're going to subtract 9. Which makes the common difference negative 9. So that's one of the pieces of information we need. The other is the first term. And it's clear that the first term of our sequence is 13. Remember, that's t sub 1. So to find any term of this sequence, t sub n stands for the nth term. You're going to take the first term and add the common difference times n minus 1. Notice that in my formula that I just wrote, d and n minus 1 are in opposite positions from the slide you just saw. That's okay because the order of the multiplication shouldn't change your final answer. And now our only job is to put appropriate numbers in the appropriate places. So again, the nth term, the term we're looking for, is equal to the first term plus the common difference times n minus 1. Instead of plus negative 9, you're always, of course, welcome to just write minus 9. And then we want to simplify. So our final answer is that to find the nth term, you take negative 9 times n and add 22. That's a formula to find any term of this sequence. Here's another example, but I'm not going to talk through this one because it's very similar to the last one. Here's the formula, and now we're going to use that formula to answer the rest of the question. Find the 31st term. So to find that, we're going to plug in 31 for n. The 31st term is 8 times 31 minus 5. That simplifies as 248 minus 5, which is equal to 243. Now, it may be tempting to pull out your calculator, start at 3, and just say, well, I'm going to add 8 until I get to the 31st thing in this list. That works okay for smaller things, but we'll use the next example to show why that's impractical, and the formula is actually a better idea. So here we're looking for the 1000th term. Clearly, you're not going to want to add a common difference in your calculator 1,000 times. That's definitely much longer than finding a formula. Now that you've seen one example, pause the video, try this one on your own, And then if you're having a hard time, you can play the video and I'll show you how it goes. Here we go. So the common difference is 10. And it's easy to tell from this sequence also that the first term is 17. We can use those to write a formula for the nth term, which is the first term plus the common difference times n minus 1. And simplifying, we get 17 minus 10n plus 1. Remember, you're distributing that negative, which is negative 10n plus 27. So our formula for the nth term is t sub n equals negative 10n plus. Now that we have a formula, we can use that to find the thousandth term. So we'll use n equals 1,000, which gives us negative 10 times 1,000 plus 27. This is an appropriate time to pull out a calculator. So we can do negative 10 times 1,000 plus 27. And the thousandth term then is negative 9,973. If you need to find many of the different terms of a sequence, the table function in your calculator is really helpful. We use that a little bit in Chapter 10, and we'll review how to use that right now. To use this formula with your calculator, you're going to enter the y equals menu, which that arrow is pointing to. If you already have an equation there, clear it out, and then enter our equation using x instead of n. To get from your equation to the table, you'll choose second and then table. And as you scroll down, you can see that these are the terms of your sequence. Now, you don't want to scroll all the way down to 1,000, so let's talk about how to do that in your calculator. Choose second, then table settings. Then use the arrow keys to go down and change the independent variable from auto to ask. Now, if you go back to your table, you can input any value you want for n and get the nth term of that sequence. The next level of problem is a little more challenging because instead of giving us the entire sequence, they give us just the 8th term and the 12th term, ask us to write a formula for the sequence, and then find the 40th term. So first we need to ask ourselves, what are we missing to write a formula for this sequence? Well, our formula depends on the common difference and the first term. So those are the things we're missing, and there are two ways to find those. The first is to start by finding the common difference using the two terms that they gave us, and then we can work backward if we know the common difference to get back to the first term. It involves a few more steps, but it's a little more intuitive. The second way is to find both the common difference and the first term at the same time by writing a system of equations. Fewer steps, but maybe not as natural to you. We'll start with the first method. So if this is my 8th term, then there's the 9th, 10th, 11th, and here's where my 12th term goes. The 8th term is 60, the 12th term is 48. And of course, I know that to get from one term to the next, you add a common difference. So if I add enough common differences to get to the 12th term, it looks like from the 8th to the 12th, I add 4 common differences. So it must be that the 8th term plus 4 times the common difference is the 12th term. So this is a pretty simple equation. We can solve it for d, subtract 60 from both sides. I get that 4d is equal to negative 12, which means d must be negative 3. Now that I have the common difference, I can use the formula that the nth term is equal to the first term plus the common difference times n minus 1 to solve for the first term. And I have some terms that I can use to plug into this equation. So we're going to use the 8th term because that's one that they gave us. It must be true then that the 8th term is equal to the first term plus the common difference times 8 minus 1. The 8th term of this sequence is 60. So I can substitute 60 into this equation, and now all I have left to solve for is the first term. So 60 is equal to the first term minus 21, which means the first term must be 81. Now that I have the first term and the common difference, I can write a formula. So it must be that the nth term is equal to the first term plus the common difference times n minus 1.